Hello and welcome to another edition of the InfoQ podcast. I'm one of your hosts, Wes Rice, together with Daniel Bryant. The InfoQ podcast aims to bring chats with engineers shaping and pushing software forward today. Today on the podcast, we're talking to Victor Dibia about machine learning in the browser. Topics today, we'll touch on YML in the browser. What are some of the use cases? We'll talk about comparisons between running machine learning with Python with JavaScript now. We'll talk about differences between client side and server side, and we'll talk about use cases and challenges, opportunities, a bunch of things that all relate to machine learning in the browser. Victor is a research engineer with Cloudera's Fast Forward Labs. Prior to this, he was a research staff member at IBM TJ Watson's Research Center in New York. His research interests are the intersection of human-computer interaction and applied AI. He is a senior member of the IEEE. Victor has published works at venues like the AAAI Conference on Artificial Intelligence and the ACM Conference on Human Factors and Computer Systems. His work has been featured in outlets such as the Wall Street Journal and VentureBeat. He holds an MS from Carnegie Mellon University and a PhD from City University of Hong Kong. As always, thank you for joining us on your jogs, drives, and commutes. Victor, welcome to the show.
Thanks a lot, Wes. It's great to be here.
I'm glad to have you. All right. So before we jump into ML in the browser, I saw when I was doing some research that you had your doctoral research. You founded a company called Dibia. It's a company focused on building products for African emerging economies. It sounds super interesting. Why a company focused on emerging economies? Surely, a mobile app, or is it a hot dog or not, or something targeting North America is going to have a much wider audience. Tell me about Dibia.
Right. So I guess before I jump into that, I'd like to mention that this was a while ago. And so this was about in 2011. At that time, I had just finished my degree at Carnegie Mellon University. It was a master's in information networking. And I decided to move back to Africa to make some contributions in what was a really young and growing tech ecosystem. And as part of that process, I took a teaching position at a university in Lagos, Nigeria. And I also founded a company called Dibia, and focus as at that time was building products for Africa. And so touching on your question as to why Africa, there were a few things that made that really interesting. And so the first thing was related to timing. So as at that time, the internet was just becoming proliferated in cities across Nigeria. And what that meant was that for the first time, the average consumer had a smartphone, and this smartphone had a data plan. And so suddenly they had access to app stores, and they were connected to the same kind of experiences that everybody across the world, across Europe and North America had. But one of the things that happened, and it showed up really fast, was that there was very, very little African content on many of those platforms, because the entire system was designed, for users in North America and users across Europe. And so this was one of the things that I and a few other people saw as a challenge. And one of the goals there was, how can we start to create African content and start to monetize this content such that we can build self-sustaining businesses and products. And that's kind of what underpinned this whole idea of building products focusing on Africa. And so with regards to exactly what we did a few things. Of course, with startups, you try a couple of ideas until you find something that works well. But one of the first things we did was that we spent some time building some educational games. And so one of the projects I was really happy to work on was something called Giddy Games. And it was an Android game. And the goal was to help players essentially learn African languages. And so in Nigeria, there are over 200 different languages. It's slightly unusual, but it's a really interesting space. And of these 200 languages, there are 3 big languages. And so what we did was that we created a kind of Fruit Ninja sort of slash kind of puzzle game. But the goal here was that you will learn translations between English and some of those local languages. And so that was quite a bit of fun. The second project we worked on was an automated ordering system for companies in the hospitality business. And so just some kind of interface that lets clients at hotels and restaurants order food online and send essentially their orders and their requests to some kind of backend system. And so those are the two things, but all of this was focused on mobile. And so that's the first 2 main projects we worked on as at that time. And we also did some work building e-commerce payment integrations. And so again, for the first time, customers could actually start paying for goods and services online. So we're working with banks to get their payment gateways integrated into mobile applications such that, people could actually start making transactions and actually paying for goods and services using their mobile devices. And so that's what that work looked like, but it feels like a lifetime ago now.
So today, what I wanted to talk about was machine learning in the browser. So this is kind of a preview a bit for a talk that you're going to be doing at QCon San Francisco. So the talk is ML in the browser, interactive experiences with TensorFlow.js. So the very first question is why? Why machine learning in a browser? First off, it just doesn't seem like the place I would want to target. Why in the browser?
Yeah, that's a question that, comes up. So it turns out that there are a few interesting benefits you get when you actually start to deploy machine learning models in the browser. And so, yes, it's important to acknowledge that there are limitations with this. And so I guess the first thing that comes to everybody's mind is that the browser is a resource constrained environment. And so what that means is that there's a cap or limit to the kind of computation you can efficiently perform in the browser. However, once we get beyond that, there are tools like TensorFlow.js that helps us move a little bit beyond that. Once we get beyond that, there are some good, interesting benefits you get from deploying models in the browser that would make it worthwhile. And so, first of all, the one I find most interesting and most compelling has to do with privacy. And so it's often the case, essentially, that when you deploy machine learning models for customers, essentially you have them send their data to you. On your servers, you pass that data through some model, you make some predictions, and you send the result back to them. And in many cases, this data is sensitive and it's private. And you then go ahead and promise the client that, your data has come to our servers, but we don't store it and we don't misuse it in any way. But what if there was a stronger proposition that says, we offer you the service using a model, but we never see your data? And we can do that because all of the computation lives in your browser, it lives on your machine, and it never gets to the server at all. And there's a really excellent example that's been discussed in the JS community and also by Google when they talk about TensorFlow.js, some implementation by Uber, where as part of the user sign-up process, a user is required to upload an image. But something that tends to happen is that some users may upload images with sensitive information. For example, some might upload their driver's license. And it's important to let this user know that, the image you just uploaded, it potentially contains sensitive information. But at the same time, you want to let them know that we're able to tell you this, but at the same time, we haven't seen your sensitive information. And so Airbnb, as part of their user sign-up process, they have a model in the browser that essentially checks if the image uploaded by the user contains sensitive information. And right there, before any information is sent to the server, they tell the user, you probably want to select a different image to maintain your privacy. And I think this is an interesting, compelling use case. And so there are many other ways in which businesses can build on this and create or craft this sort of simple, interesting, private interactions for their users.
Yeah, it makes sense. Let's break that down a little bit more, though. In order to do something like that, we still need to train on a corpus of data on the back end, develop a model, and then deploy it on the client side, right? What's that experience look like? Are we only scoring on the browser, or are we able to actually train and score in the browser?
Yeah, and so I guess this leads us to another question. What is a typical workflow for deploying machine learning models in the browser? And so if we go with the example I just discussed, the Airbnb example, where we have a model running in the browser that's able to identify if an image contains sensitive content or not. And so a really good, interesting workflow for that would be something I call the offline workflow. And so this offline workflow, what it means is that we have a model trained in some offline backend process. And it's a typical machine learning flow where you go ahead and you assemble images of what that represent sensitive content. And you also possibly assemble your data set containing normal acceptable images. And you train a model that's able to classify between if an image is likely containing sensitive content or if it's a benign normal image. And so you could use your GPU clusters, your TPU clusters, and train a really good model. And then when you're done with that process, you could then export the model, then convert it into TensorFlow JS web format, and then have that deployed in your JavaScript web application. And in this case, you typically just use it for scoring inference. And so this is one of three potential workflows, and we could talk about the workflows that are available at some point during the conversation.
What about distribution? Doesn't browser help you around distribution?
Right. So yeah, ease of distribution is another interesting benefit you get when you deploy models in the browser. And about 3 years ago, I do have a couple of friends, software engineers, who were interested in getting into machine learning, but they gave up because they just couldn't install TensorFlow or actually get it to work correctly on their local machine. And of course, 3 years down the line, things are much better. You can easily do pip install TensorFlow or counter install TensorFlow. But the problem is, if you wanted to bundle this whole environment within an end user application, this process can still be fairly complicated. And so there's this whole process of installing TensorFlow, installing dependencies and drivers. However, if you go the JavaScript route, it's an extremely straightforward process. The user just goes to a website or URL, and essentially they have access to the entire application module. And even going beyond deploying machine learning models in end user experiences or end user applications, as a developer, essentially if you're building a library that provides some kind of function, it's much easier to wrap that library as a JavaScript library and make it available to other developers in the JS format compared to, let's say, Python. And so there's a library I've created, HandTrack.js. It's an object detection model that allows you to track hands and images. And so I have 2 versions of that. And so the first version is in Python, and the second version is bundled as a JavaScript NPM package. And so if you go and look at the issues on the Python version, about 80% of them has to do with things like, oh, I have a new version of TensorFlow. It doesn't work. I tried to install TensorFlow and load the model. This doesn't work. And so all the issues have to do with setup, installation, as opposed to actual issues around the model. And the exact opposite is the case with the JavaScript version. So with the JavaScript version, people actually have questions about the model, its performance, its accuracy. And that's because it's a very simple one-line install. And so developers just go ahead, include the JavaScript link, and they have machine learning models for using their JavaScript application.
It's interesting that you bring up language, because my first instinct was to ask JavaScript with machine learning. That's not the language that I hear most people talking about. So is it the fact that it's in JavaScript, it's making machine learning more approachable to a larger segment of developers, or is it making it harder for machine learning engineers to actually get onto the web?
Right. So I think historically, probably one of the main reasons why JavaScript is not associated with machine learning is because machine learning tends to be a resource intensive, high computation kind of process. And so you need to parallelize computation in many ways. Many times you need to write multi-threaded applications, and JavaScript is pretty much not designed for this sort of complex manipulation by default. So I guess that's probably a historic reason for this disconnect between the JavaScript community and the machine learning community. However, it turns out that on GitHub, based on the last GitHub developer survey, JavaScript is the most popular language based on the number of repos that actually use it.
Undoubtedly.
Yeah, there was a survey also on Stack Overflow of over 90,000 developers. We see the same thing. JavaScript is the most used language, JavaScript and HTML. And in addition, the language people want to learn the most. And so JavaScript is right there in the top 3. And so I think it's a good time with the emergence of libraries like TensorFlow.js. It's a good time to make these capabilities now generally available to front-end developers who probably were interested in using machine learning, but essentially just haven't been comfortable using Python or other backend languages.
Okay, but I have a question. So JavaScript's got the event loop. It's like we're processing a single thread. We're talking about machine learning models. We're talking about massively parallel linear algebra. How is JavaScript doing that?
Right. So the primary limitation of the browser being single-threaded, that still remains. However, with libraries like TensorFlow.js, there's opportunity to kind of accelerate some of the computations that are done. And so how TensorFlow.js handles that is that underneath it uses the WebGL library. And so the WebGL library is a fairly popular standard for accelerated computer graphics in the browser. And pretty much if there are GPUs available on a machine, WebGL has access to those GPUs and can run accelerated computing there. And so essentially TensorFlow.js just takes advantage of that. And essentially that's how it kind of speeds up computation in the browser. But yeah, you also raise an important point. JavaScript is single-threaded. There's the event loop. And what that means in practice is that the developer has to be careful such that they build their application such that it does not block the entire UI thread. And so these are some of the things I will try to cover in a little bit more detail during the talk at KubeCon.
Okay, so let's talk a little bit more about, I guess, the developer experience about developing machine learning models for the browser. So what does it look like? Are you able to debug? Are you able to observe and instrument when you're deploying to a browser? What does that experience look like?
I like to think of the experience as three main flows. And so I'm just calling them, for lack of better terminology, the online, the offline, and the hybrid flow. So the online flow is where you write with TensorFlow.js in your browser, you design your model. So essentially you specify the building blocks, LSTM, CNNs, all that good stuff. You get some data. It could be data that's downloaded from a server. It could be data contributed in real time by the user. It could be that the user is taking pictures from the webcam directly. It could be that they're typing in some text and you feed that data to the model that you've designed in TensorFlow.js right in the browser. And you train that model and then you use that to do some kind of scoring. And so with TensorFlow.js, you can conduct the entire process in the browser. And so that's the online flow. Clearly, the caveat here is that it will only work well for small models, not very complex models, and also for small data sets, because for very large data sets, you most likely do not want to train large models using large data sets in the browser. So that's the online flow. The second flow, which is fairly more common, is the process where you could go ahead and you could use TensorFlow Python with Keras to build your model on some GPU cluster. So you structure your model, you train it with some data. Some models might take days to train depending on what you're working on. And then you could go ahead, export that model, say in the TensorFlow seed model format or the Keras model format. And then you could take that exported model, use the TensorFlow.js converter, convert it into the TensorFlow web model format. And then you can then import that directly into a JavaScript application and use that for inference only in the browser. And so for fairly complex use cases where you have a lot of data and you have a fairly complex model, typically you want to follow this offline process and then just import your model for scoring in the browser. And then there's the final hybrid process where you do the same thing as the offline process. So you train offline, you convert to TensorFlow.js, and then right in the browser, you could get some additional data and use that to fine-tune your model right in the browser. And so it might be the case that you want to personalize the model to your exact user's experience. And so you could just take a few samples and using transfer learning, you could fine-tune the model to improve its performance just for a particular user context you're interested in.
But what about that fine tuning of the model? So, like, you can get a model, you can get it into the browser. How do you know it's right? Does TensorFlow.js have ways that you can like instrument and observe what's happening to be able to understand if the decision you're getting is a good decision?
Right. And so the TensorFlow.js API, it has two APIs. And so the first API is a low-level linear algebra API, which, except you really know what you're doing, you probably should not use that. And so the second API is a high-level layers API. And so that's fairly close to the Keras API. And so most of the way you can reason about a neural network model in Keras, you could pretty much use the same process and reason about a TensorFlow.js model created using the layers API. And so what that means is that you could do things like compile the model, you could look at accuracy metrics, you could look at compute your F1 score, your F2 scores. And in addition, I think there's some visualization libraries also that I think it's still in beta, but something slightly similar to what you have with TensorBoard, where you can visualize properties of your model and also properties of training if you're doing training or fine-tuning right there in the browser. And so there are some visualization libraries that perform this kind of debugging. But in addition, most of the compile accuracy tracking capabilities you will see in Keras, you will also find similar comparable methods in TensorFlow.js.
So that actually brings up another question, and that's like binary compatibility between like TensorFlow.js and TensorFlow on the server or Keras on the server versus the layers API with TensorFlow.js. What does that look like? It's obviously not binary compatible, but how close are they? How similar are they? Or is it just very similar, or is it two separate teams that are trying to go the same direction?
And so with regards to how you could get existing models functional in the JavaScript environment, this is mainly accomplished using the TensorFlow.js converter. And so the converter supports three types of model formats. So the first is the TensorFlow seed model format. And so if you've used TensorFlow Python, you're typically able to export your trained models in the TensorFlow seed model format. if you've developed any models using Keras, Python with TensorFlow backend, you can export any of those models using the Keras model format. And then finally, if you've used TensorFlow Hub, so TensorFlow Hub is just an online repository of pre-trained models that have been made available by the Google AI team. You could take any of those models and actually just convert them directly to JavaScript format. And so those are the three models that the converter supports. And so what that means is that if you have PyTorch models, there's no conversion format to TensorFlow.js. And so you're kind of limited if you actually have your models trained by PyTorch.
What about the ecosystem around TensorFlow.js in particular? So, for example, you talked about taking a model, putting it out there, and scoring or doing inference out there. Are there libraries and tools to help you like A/B test to be able to manage getting it out there? What does that kind of like whole larger ecosystem look like about deploying TensorFlow.js models?
That's a great question. Right now, I really haven't seen models specifically designed just to evaluate and test TensorFlow.js models. But the good news is that typically the performance of your model would remain the same before you convert it to TensorFlow.js format.
Oh, really? Okay.
So typically you would expect similar, pretty much equal performance after the conversion.
Interesting.
So with that, the entire suite of tools like the TensorFlow.js ecosystem, it allows you kind of manage the whole pipeline of collecting data, model validation, input data validation, model training, model validation, and model promotion. You could use that entire pipeline up until the part where you select the right model to promote to production. And just before you promote that, you could have one additional step that exports the model to multiple formats. And so it might be that you're running the same model on multiple systems. You have it running on some backend GPU cluster, and you have a version of it running in the browser. And so you could use the exact same A/B testing and pipeline management tools that you have. It could be TensorFlow extended. And right at the end of that process, you just export the model to multiple formats. Then you have TensorFlow.js.
That's cool. What I just heard you say, given the same amount of resources, a model that you build and train and run server side will perform the same as a model deployed to a browser?
Yes, that is correct. But there clearly is some caveat here.
I was about to go, and where's the gotchas?
There definitely is some caveat. And so deep learning models tend to be large. And so just to give an example, the recent models like BERT and GPT-2, they can be as large as 500 megabytes and more. BERT, Elmo, all of that. And so they could be as large as 500 megabytes. And so in JavaScript latency terms, 500 kilobytes, it's already a lot of data already. And so the idea is while you develop your model, the goal is to always optimize for size and latency. And if this process is done correctly, if you essentially optimize your model for size and latency, you should get about the same performance on server side compared to client side. And so in the example library that I'll talk about, I'll kind of discuss in detail at my talk. So we use the mobile net architecture, which is optimized for mobile devices and resource constrained environments. And we train a model. And we get similar performance when we run that model in Python on a laptop computer compared to when we run it in the browser. And so the performance is pretty consistent, but I guess that works because on the line, we have a model that's optimized to run on mobile devices. And so the size is not that large. And so for that specific model, it's about 18 megabytes, which is to download. Essentially, when the application loads, you need to download 20 megabytes of material. And so that kind of slows down the experience at the beginning. But once the model is downloaded, everything works fine.
So let's talk about size for a second. The question that I had in my mind was to ask you, we've been talking about browser, but to talk about like node and server side. And specifically, I was going to ask about serverless. But in like the example you just mentioned, you're talking 18 megabytes. It's way above the limitations of what a serverless. Is this too large to be able to target like a serverless environment? Or can you get it down to under 5 megabytes where we can deploy it in like maybe Lambda?
Yes. And so one of the reasons I'm excited about machine learning in the browser is because there's been a lot of advances in a research area known as model compression. And so model compression is all about how can we make models smaller. And so one of the interesting areas there is something called model distillation, where we have a large model and we train a smaller model to replicate all of the capabilities of the large model. And so using approaches like this, I think there's some recent work that shows how you could take BERT, almost a 500 megabyte model, and you could distill it into a small version that's about 7 megabytes, almost 60x compression, less than 5 to 7% drop in accuracy. And so these approaches are still fairly experimental. You see them mostly in research papers, but I think we're at the point where it's making its way out of academia and becoming something that will likely become available as a model compression tool that'll let us, start to take some of these models and get them so small that hopefully, we see high performance models in the less than 5 megabytes range. This is still ongoing work. This is a field that's still developing. It's hard to tell, but I think with the next few months, we will see performance models compressed to the level that they're able to fit into serverless applications.
Very nice. All right. So as I mentioned, when we kicked off, you are doing a talk at QCon San Francisco. It's called ML in the Browser, Interactive Experiences with TensorFlow.js. Preview it for us. Tell us about what you're going to talk about. Obviously, machine learning in the browser, but maybe go a little bit deeper than that.
Right. And so I guess for the talk, I'll revisit the motivations, essentially why this whole topic is important, with some additional examples that should get the audience thinking about, interesting use cases for them to begin to experiment with ML in the browser. I'll also spend some time in detail looking at the TensorFlow.js API. So looking at examples of using the low-level linear algebra library, what that looks like, and also some examples of the high-level layers API. And then finally, I'll spend some time discussing an end-to-end example building HandTrack.js. And so HandTrack.js is a JavaScript library that uses a convolutional neural network for object detection. And what that does is that it lets you track the location of human hands in any image. And just some examples of what developers have actually experienced that people have built with that library. And so along the way, I'll also discuss some challenges associated with machine learning in the browser, some good best practices and how to optimize your model. So touching on things like selecting the right components that ensure that your model is kind of small at the end of the day. And then also touching on topics like model compression and future web accelerated computing standards that might make this whole area more interesting in the future.
Very cool. Well, Victor, thank you for taking the time to talk with us. Thank you for doing the talk at QCon, and I look forward to seeing the talk in just a few weeks. Thanks for joining us.
Thank you. Thank you, Wes.
What is happening in the programming language world? Which language has gained wider adoption? Check the Programming Languages Trends Report to make informed mid- and long-term decisions or to choose wisely where you invest your time.